Problem number 9. A 500 Newton box is placed on a 30 degrees incline with a coefficient of friction of 0.6. Will the box slide down the incline? So let's draw our incline and work from there using free body diagram on a incline. So this is an incline. So I'm going to place this box about in the middle because it's easier to draw all those lines. So this incline is 30 degrees. And the box is 500 newtons. So what I'm gonna do is, first I'm going to find the center of mass of this box, and I'm going to draw a very fine line to set a grid on this box. Then I'm going to draw the weight force straight down, and I like to pass the incline, the triangle, and this is 500 Newton. So then I'm gonna use the tip of this vector and draw another fine line to close this rectangle. And now I can find the components, which is this one, I'm gonna call FGY, and this is FGX. Now the angle here is the same angle of the incline, which is 30 degrees. Okay, so to complete this free body diagram, we need to draw the normal force, which is normal to the contact surface. So this is the contact surface, and the coefficient of friction between the box and the incline is 0.6. Now, if the box is possibly sliding down, we have a force that opposes this motion, that is the friction force. So with this, I complete all my free body diagram, and now my next step will be calculate the components of this weight. So temporarily, I'm going to move this vector FGX. I'm not doubling, I'm just moving FGX at the bottom of this right triangle so I can calculate the components. So let's use this space to calculate FGX and FGY. So I always use sine and cosine for the components, like I mentioned before. So you need to ask, what is this side for this angle? So this is opposite of this angle, so you are gonna use sine. So sine of 30 degrees is the opposite over hypotenuse, which is the weight. So the weight was given is 500 newtons. So 500. And when you do cross multiplication, your FGX is 500 sine of 30. So now let's set up on the other side. So FGY is adjacent for 30 degrees, so I'm using cosine is FGY over 500. So my FGY is 500 cosine of 30 degrees. Now I'm using my calculator. So you'll be 500 times sine of 30, which is FGX is 250 newtons, and my FGY is 500 times cosine of 30, which is 433. I'm gonna leave like that, newtons. So we have the components of the weight of the box. So next, so this is the components. Let's keep these numbers. So we did the free body diagram, we found the components. Now we are going to use, well, we have to go back to the question. So will the box slide? So now we need to look two things about this. For the box slide, FGX must be greater than the FF. So if the problem is mentioned the box is sliding, is because I'm not going to consider these forces are in equilibrium or equal. However, on the vertical direction, our Fn, that I didn't label here, our Fn and Fgy are equal. So our Fn is equal to Fgy. So those are in equilibrium, so they are equal. So I have, and then I'm looking, okay, FGX I have, which is this, but I don't have FF to compare. So we need to calculate FF using the formula of coefficient of friction. I mean, force of friction. So the force of friction, the formula is coefficient of friction of mu times normal force. So the coefficient of friction was given, is 0.6 times Fn. Now Fn is equal Fgy, which is 433 newtons, right? So 433 here. So when you multiply this number that I already had in my calculator times 0.6, so we have 259.8. Let's round to 260. So FF is 260 newtons. Okay, so just let me write this down one more time. Okay, so just make sure that I have everything in a box so I can compare. All right, so I have my FF value and I have my FGX value. So now we are going to compare FGX with FF. So if my FGX is greater, so FGX, let's compare FGX with FF. My FGX is 250 newtons and my FF is 260 newtons. So looks like this box is not going to slide because the force of friction is greater than the horizontal component of the weight. So this box will not slide.